Hey everybody, this is Larry. This is day 9, of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, how Leetcode's been doing with these deemed weeks or deemed days or whatever. Because, I mean, I don't know. I don't know if you're joining me recently, but if you're joining us only for this month, you'll notice that the last couple of problems are like top KE and or just heap related, right? Which kind of always gives away the game. I think the hardest part of solving a problem isn't necessarily knowing what to do with an algorithm. I mean, it may be when you're starting out, but it's that identifying which algorithm to use. And if you have a hint that it is going to be heap, it makes these problems a lot easier, or at least it gives the trick away a little bit. And also, if you're at home, yes, if you're a long time viewer, or at least maybe just a viewer for last week, you'll notice that I did get a haircut. Thanks. In fact, I got all of them cut. Anyway, yeah, I just see top K, so let's see how this goes. A little bit, I don't know. I mean, I get why they want to do that, but I also feel like that makes it just awkward, because you can just do like people who wants to have a deemed week or deemed practice, they could just do that. I think for me, it's just about exploring and discovering what you don't know, right? And it's a little bit awkward. Anyway, today's problem, even though I made the same complaint like the entire, it's been a month, I think, probably the same-ish complaint on different problem sets. So I don't know. So maybe you're sick of hearing it, and my bad. But anyway, today's problem is 347, top K frequent elements. So given an integer array nums and integer K, return the K most frequent elements. You may return the answer in any order. And the any order part is kind of cute because that means that you can, in theory, get away without you could, in theory, get away with certain things depending on how you want to do it. But yeah, it must be better than n log n. Is it like strictly better than n log n? I mean, I guess the answer is going to be heap when it's going to be n log k or something. I didn't even really think about it. But okay. So the first thing to do is, what's k? Oh, k is the most frequent element. What if k is more than, the number of unique elements. So the first thing to do is, of course, count the elements. I think that's reasonable. So let's just say count is equal to collections.counter of nums. This is just Python for being lazy. But lazy is a virtue, of course, in reusable code. So there's that. And basically all it does is just put all the elements in here and kind of put them together. And then the next thing is the same thing that we've been doing all week, which is, top K, bottom K, something K. We just want to keep track of them in a heap, right? So in this case, this is the most frequent, meaning that you want to keep track of the most frequent. So you're going to use a min heap to be clear, because you want to remove the least frequent numbers from the thing. I do want curious what happens if like there's a tiebreaker. The answer is unique, so I guess that's okay. Though the phrasing is not as tight, I guess, in the sense that the answer is unique and you can return the answer in any order. I get what they're saying and I appreciate it, but it's not as mathematically tight. But this is an older problem statement, so and for me, I don't need to be mathematically tight, but sometimes they get like, as long as they're consistent about it, it's okay, right? Sometimes like you assume that they ask you for certain things, and then suddenly the input is like random negative numbers, and you're like, well, maybe that's not a good example, but something weird that's inconsistent. But instead of just like like well-intended, like solve the problem, not solve weird edge cases that you didn't think about because you were solving the problem. Anyway, that's another rant for another problem. This is a good thing, so let's go. But now that is just for, I think it's items, but for key and count in count.items, we could print it out just to kind of show you what it looks like at home, and then we'll put it in a heap. And as we said before, it's going to be a min heap. So that's going to be the key. Number 1 appeared 3 times, so this is kind of symmetric in a wonky way, meaning that it's a little confusing. But so now you have a heap, and in different languages it's going to be different, so make sure your language is consistent. with what you believe you're solving. In Python is min heap. In other languages, very often actually is max heap. The way that I solve these things is by using tuples as a hack, because it basically does pairwise min on each component. So basically, it means that it quote unquote orders by the first element and then tie bricks by the second element and so forth. So that's basically what I would do. And of course, then here we will push to the heap the count, because we want a min heap. So yeah, so the count is okay, and then the key as a I don't know, just because you would like to know the key. That's part of the solution. And then of course, if awkward, because I will keep a k. Okay, fine. Because we shadowed the k here is why I said whoops. But yeah, but if the length of the heap is greater than k, then we can pop, right? And in popping, we should be explicit in saying that we're getting rid of the minimum element, which means the least frequent element. Yeah. And then now once we're done, we can actually take the heap directly, because we can return in any order. You could do repeat popping if you like. You can just take the heap in array format and just return it if you like. Of course, you have to convert it to get rid of the count and just have the key. But that's basically the idea. And that's basically what I'm going to do. What's it called? Yeah, key for the count, key in H, right? Something like that should be good, I think. Yeah. Oh, I always forget. It's very awkward because it's not it doesn't have OOP syntax, so I always forget about the actual heap in the parameter, because in most languages it is a member function on a heap, but in this case it's actually a library on a list. So it's a little bit awkward, but just to be clear though, that does not make this not OOP. It just means the syntax doesn't have OOP sugar, synthetic sugar, right? Because it still follows all the principle of OOP, except for that instead of using the Pythonic OOP syntax, it just uses the object as the first parameter. That still makes it OOP per se, at least in the And if you do a lot of old school C code, you'll see that all over the place. So yeah, so that's just kind of a little bit of a trivia for you at home, because sometimes people may be tempted to say that this is not OOP. But yeah, let's give it a submit. Oh no, I had a wrong answer before. Hopefully I don't have a wrong answer this time. Yes, beat you, old Larry. What did I get a wrong answer on? What was I doing? I did do the thing. I mean, this is more awkward, but I think this is right. What did I get wrong here? Dun dun dun. Huh. I am curious. What did I get wrong? I did write out the counter thing though, but huh. Why is this wrong? Did I mess up? I'm confused actually. Past letter K is in the range. Why is this wrong? Okay, let's I'm always trying to learn from past mistakes, though we should analyze today's solution first. But let's see. What did I change to fix this? Oh. Huh. Oh, I see what I did. I just had the signs wrong. Wow. That is subtle. That's kind of actually also why I start writing it in a different way, so that, because I think back then, I think I changed it a little bit mentally, but the idea here is that I keep the, for this, I forget which one's the right one. This one's the correct one, yeah. I keep the invariant, and invariant is something that I talk about in this channel, but the invariant of the problem is such that heap will always have at most k elements. But one thing that I've been doing a little bit, and obviously you look at the code and it's slightly tighter, is that the invariant here is that it can have k plus 1 elements. And then if it does have k plus 1 elements, we pop this throughout the life, and then at the end it still only has k elements. Depends on how strict you want to think about it, but this is obviously much closer, and you can obviously just compress this a little bit more as well. But I'm not here for the shortest code. So yeah. So anyway, the analysis is going to be the same as almost every problem that we've done this week. So this is not that interesting. But this is going to be O of n time and O of n space for the collection piece only. This part. Because that's just how much time and space it takes. Maybe you could say U for the number of unique elements, but I'll skip that for now. And then here, as a result, this also has O of n loops, iterations, and of course, a push and a pop both is log k, because as we said, the invariant here is that heap will have at most k elements, and therefore it will take at most log k time. Right, so O of log k time. So this is going to be O of n log k time. And technically, I guess if you look at this and also here, it's going to be plus n, but that obviously is dominated by n log k. So yeah, and O of n space, both for here and also the return result. I guess this is actually technically O of k, so I'm wrong here. But n plus k, which should be O of n in either case, because of this thing in theory. Yeah. I think that's all I have for today. This is Friday, so maybe Saturday in your place. Have a great weekend. Let's get them this weekend on the contest if you're doing it, and let's have fun. Stay good, stay healthy, to good mental health. I'll see you later. Bye-bye.